Loud and clear, no? Okay. Right. So today is day 3. Day 3. Week number 2. Day 3, week number 2. So today a lot of work because we have to do day 3 questions as well as what? Day 4 questions as well. There, we'll try our best. At least we'll solve 1 or 2 day 4 questions. Okay. Right. Right. Moving on. Start work. Right. Okay. Which of the following optical elements, there you go, which of the following optical elements could turn a ray of light as shown in the figure? Could turn a ray of light as shown in the figure. Right. So the ray of light is coming this way and bending that way. Now this is familiar what in a prism for sure. This is familiar in a prism. He is also familiar in a convex lens. Now how? Convex lens, you can assume it's made out of 2 prisms. Concave lens also, you can consider made out of 2 prisms like this. Now here the prism, of course, is normal. This is a normal configuration. Light rays come here, they go down. So the same thing can happen here, no? The same thing can happen here. So in all 3, this is possible. Correct answer is answer number 5. Correct answer is answer number 5. Okay, no? Correct answer is answer number 5. Right there. This path of light is possible in a prism. This path of the light ray is possible in a prism. And convex and concave lenses, can also be made using a prism. Can also be made using a prism. As indicated below. As indicated below. Okay, no? Right. Okay. Moving forward. Look at this. A certain person has a defective eye. So they already said defective. The distance between the eye lens and the retina is 0.025 meters. But the power of the resting eye is 45 diopters. What should be the type and power of the correction lens he should wear in order to see distant objects? Right. Power is given. Power of the resting or relaxed eye is given. 45 diopters. Focal length is 1045 meters. That means if you simplify it, minus 100 over 45 centimeters. If you divide it by 5, 5 times 9, 5 times 20, here minus 2.22 centimeters you will get. This is for far vision. That means light rays, diameter here 0.025 meters. That is about 2.5 centimeters. But light rays coming from infinity, the relaxed eye means light rays are coming from infinity. Light rays coming from infinity will converge exactly in front. 2.22. So what kind of defect is it there? Short-sighted. Short-sighted. Can't see infinity. Can't see infinity. First of all, remember relaxed eye means looking at infinity. Relaxed eye means looking at infinity. So here you go, the basic calculation. This distance only is 2.22 centimeter. 2.22 centimeter. Okay, no? Right. What should be the type and power of the correction lens he should wear in order to see distant objects? In order to see distant objects, right? Now, how do you make the correction? How do you make the correction? Right, to correct it, here you go the eye. We must make sure that light rays converge on the retina. So light rays converge on the retina means light rays coming from infinity will then converge on the retina. The effective focal length is 2.5 centimeter. So here, no need to calculate. You can see clearly light rays coming from infinity. Effective focal length, very simple, minus 2.5 centimeter. So 1 over effective focal length is 1 over focal length of lens, 1 over focal length of eye. So here, effective focal length minus 2.5. Focal length of lens we don't know. Focal length of eye, there you go. I'll put in fraction form minus 20 over 9. Simplify this. Minus 10 over 25 plus 9 over 20, 1 over focal length of lens. Common denominator 100 minus 40 plus 45, 1 over FL. Simplify this. FL equals, turn upside down, 100 divided by 5. 20 centimeter plus. So concave lens 20 centimeters. Concave lens 20 centimeters. So if you simplify it, you can get the answer. Concave lens 20 centimeters. Best to find the power. Power here to find. Right, let's find the power here. Power of the lens is equal to minus 1 over focal length 20 centimeters convert to meters minus 5 diopter. Minus means concave. No? So if you go downwards, concave lens 5 diopter. Concave lens 5 diopter. So here is your answer. Concave lens 5 diopter. Answer number 4. Answer number 4. Okay. Right. That is small sentence there. That is small sentence there. Light rays will converge in front of the retina. Light rays will converge in front of the retina. This means it is a short-sighted eye. It is a short-sighted eye. It is a short-sighted eye. When we wear the lens, the effective focal length, when we wear the lens, the effective focal length must be equal to the diameter of the eye. Must be equal to the diameter of the eye. But the focal length of the eye will not change. But the focal length of the eye will not change. Okay, no? Right. If you want, you can take a photograph, the ones who need it. Remember this, focal length of the eye will never change. What you are doing is you are changing the effective focal length. And here the effective focal length, when light rays come from infinity, is equal to the diameter of the eye. Okay, no? Right. Next one. A pulse propagates with uniform speed along. They're asking what is happening to point P. So if you look at this, point P should climb the hill first, a longer climb, and then shorter drop. Longer climb, shorter drop. There you go. Answer is answer number 2. Just follow the hill here. Climbing the hill, you're climbing the hill, shorter drop. Shorter drop. Okay, no? Right. That's easy. Question number 4. A ray of monochromatic light approach a spherical air bubble. Look at the word, air bubble. Air bubble. From a block of glass. So this is glass. That is air bubble. So if you draw a normal, the normal should go to the center, right? Denser, rarer away from the normal. Denser, rarer away from the normal. Rarer, denser towards the normal. So A is your diagram. A is your diagram. Correct answer is answer A. This is very simple. You can quickly move on. Right. A traveling microscope is focused on a mark at the bottom of an empty beaker. Empty beaker. Now, if a microscope is raised by 1 centimeter, to what depth should the water be poured? Now, here, telescope is focused to the bottom. Now, if I fill water here, bottom is slightly shifted up. That's where the image is. So, the telescope also must be shifted up by 1 centimeter. They are given 1 centimeter. Remember, the shift here and the apparent shift both are what? Same. The shift here and the apparent shift there, object here. Apparent shift there, both are same. So from here you can easily say, the apparent shift, here you have the actual depth, 1 minus 1 over refractive index of denser medium with respect to air. Refractive index of water with respect to air. There you go. The apparent shift is 1 centimeter. 1 minus 1 over 4 over 3. 1 T 1 minus 3 over 4, that is quarter. Cross multiply. T is equal to 4 centimeter. Thickness is 4 centimeter. Thickness is 4 centimeter. There you go. Answer number 2. Thickness is 4 centimeter. Answer number 2. Right. Easy, no? So remember the apparent shift here and the shift of the telescope both are same. Right there. The apparent shift and the shift of the telescope both are same. Both are same. Right. Carefully look at this. Carefully look at this. When a certain amount of matter is heated at constant rate, the variation of temperature with time is given. So here you go, variation of temperature with time is given. Here you go, it's heating. Consider the following statements made about the information that can be gathered from this curve about matter. From this curve about matter. Right. Matter shows a change of state. Now, why is the temperature not changing here? Temperature is not changing there because phase change is taking place. Statement A is correct, right there. There is no temperature change. There is no temperature change in the middle part of the graph because there is a phase change. Because there is a phase change. Right. Next one. Matter should have a large value for the specific latent heat of fusion or vaporization. Matter definitely has attained its boiling point. Now, can you come to these conclusions? Yes or no? Can you come to these conclusions? Yes or no? Matter should have a large value for its specific heat of fusion or vaporization. First of all, we don't know whether this is fusion. We don't know whether it's vaporization. It may be either, one of them. Next is Q is equal to ML. Why is it taking a long time? Q dot T. They're telling you heat at a constant rate. This is constant. Constant. Why is it taking a longer time? So this is constant. The amount of mass is also constant. So taking a longer time means here L proportional to T. Taking a longer time means larger L, but without knowing the mass. How much mass has converted, we can't tell. They are not telling you a certain amount of matter is heated. Certain amount of matter is heated. So here everything is converted in different story. Matter should have a large value for the specific latent heat of fusion or vaporization. Now, looking at this, Q dot is constant. Larger time taken means depends on the mass variation as well. So here, if you look at this carefully, right? Q dot is constant. Q dot is constant. T is constant. We don't know whether it's large or small. Right. Next is definitely attain boiling point. We can't say that. This can be ice. This can be ice converting to water. That can be what? Increasing. We don't know. So C is wrong. Wherever there is C is wrong. This is wrong. This is wrong. This is wrong. So selection is between these two. The keyword here is large value. Let's write below first. Let's write. We cannot say it has attained boiling point. We cannot say it has attained boiling point. This is because it may be fusion. It may be fusion. And just because the time is longer for the phase change, we cannot say the specific latent heat is larger. We cannot say that the specific latent heat is larger. Right? Sometimes the mass might be large. Larger the mass, longer the time. Sometimes the mass might be large. Sometimes the mass might be large. Therefore, it will take a longer time. So B is also wrong. So only correct statement is answer A. Right? So if I summarize it, first one, phase change occurs. There is a phase change. Second statement, maybe mass is large. Therefore, longer time. We can't always say specific heat, latent heat is large. Third one, definitely a certain boiling point. It may be fusion. We don't know. So therefore, guaranteed correct statement is only A. Okay, no? So these are the 3 points. Right. Look at this one. 5 identical uniform rods, some which are bent as shown are rotating about the axis. Rods are accelerated for the final angular velocity to be omega naught, which attains the highest energy. So highest energy is rotational kinetic energy. So here omega naught is constant. No? Everybody is going with omega naught. So energy is proportional to moment of inertia. Larger moment of inertia, larger energy. Which one has the bigger distribution? Obviously, this one has the bigger distribution. Larger distribution occurs here. There. Larger distribution occurs here. Right? That's right. Greater the moment of inertia, greater the kinetic energy. Greater the moment of inertia, greater the kinetic energy. Right. Moving on. If point P is maintained at constant potential 1100 volts, the potential difference across AB is given by, right, this is 0 volt, grounded, right. High potential to low potential charges can move. So all these will have the same charge. Capacitors are in series. Capacitors are in series are like resistors in parallel. 1 over 1, 1 over 2, 1 over 3. Common denominator 6. 6 plus 3 plus 2. 1 over C equivalent. Turn it. Here you have 11 divided by 6. C equivalent is 6 divided by 11 microfarad. C equivalent is 6 divided by 11 microfarad. Right. So have a look at this. Have a look at this. Now you have point P, equivalent capacitor, grounded. Potential difference there, 1100 volt, equivalent you know. So let's find Q is equal to CV. Q we don't know. Here 6 over 11 multiplied by 1100, 600 microcoulomb. 600 microcoulomb. What are they asking you? So here 600 microcoulomb, here 600 microcoulomb, here 600 microcoulomb, same charge. Now apply Q is equal to CV across AB. Charge across AB 1 microfarad. Charge is 600. Voltage V. V is equal to 600 volts. So 600 volts means correct answer is answer number 5. 600 volts means correct answer is answer number 5. Write there small sentence. All the capacitors are connected in series. All the capacitors are connected in series. All the capacitors are connected in series. Therefore, we can find the equivalent capacitance. Therefore, we can find the equivalent capacitance. Therefore, we can find the equivalent capacitance. And then find the charge. And then find the charge. From the charge, we can find the potential difference across AB. From the charge, we can find the potential difference across AB. From the charge, we can find the potential difference across AB. Right. Okay, no? Right. Have a look. Next one. Which of the following does not show 1.5 volt in a dry cell? The dry cell has an internal resistor. Now remember, when you have a battery, there is an internal resistor. here EMF, here simple R. So when a current is coming out, the actual potential difference here, is not E, right? So actual potential difference is E minus IR. Now in a battery you see 1.5 volts. What does that mean? 1.5 volts means a terminal potential difference. This is called terminal potential difference. Terminal potential difference, right? First one, terminal voltage varies with the value of the resistance connected. Terminal voltage varies with the value of the resistance to which it is connected, right? So if I connect a resistor across this, the current will change. When the current changes, terminal potential difference will change. Terminal potential difference will change, right? So that means what? First one, current will change. Current will change. Therefore, terminal PD, delta V will change. Delta V will change. That means there is an internal resistor. So it shows, this one is showing. Right. Terminal voltage increases slightly when several such cells are connected in parallel. Now, if several such cells are connected in parallel, look at the board now. Several, I think we should write this on the notepad. Look at this. So delta V is equal to E minus IR. Here you have the battery, here you have the internal resistor. Let's say you connect this across the resistor there. There is going to be current going in this circuit. When current goes in this circuit, if you apply Kirchhoff law loop, sum of EMF equals sum of potential difference. E is equal to I simple R plus I capital R. E minus I simple R, I capital R. Voltage across the load resistor is your terminal potential difference. E minus IR. So think carefully. If resistor changes, I will change. If I changes, terminal potential difference will change. So statement 1 correct. Shows that there is internal resistance. Statement number 2. You are connecting similar cells parallel to each other. If you are connecting similar cells parallel to each other, what's going to happen? Let's say I'll take 3 wheel, ER, ER, ER. What can you say about the equivalent? Look at the board carefully. Here there will be an equivalent EMF. Here there will be an equivalent EMF. All resistors are parallel to each other. R over 3 is there. R over 3 is there. Look at the board. So, what is happening here? What is happening here? Let's say this is connected across the load resistor. Connected across the load resistor. Now look at this carefully. Look at this carefully. The resistance here has reduced. The internal resistance here has reduced. That means what? Effective resistance will reduce. Effective resistance reduces means current will reduce. Current will, increase. Current will increase. Terminal potential difference E equivalent minus I times R over 3. Please look at the board carefully. What are they asking you? Terminal voltage increases slightly. Increases slightly when several such cells are connected in parallel to each other. Several such cells are connected parallel to each other. Look at the board. Look at the board. Here, what's happening? Effective resistance has reduced. Current will increase. Current will increase. Current will increase. Look at the board now. When current increases, the voltage across the load resistor will increase. Is IR, no? Delta V is IR. Current increases, delta V increases. So you can say current increases, delta V increases. Current increases, terminal potential difference will increase. Statement 2 also indicates there is internal resistor. Statement 2 also indicates there is internal resistor. Right there. When cells are connected parallel to each other, when cells are connected parallel to each other, the effective resistance will reduce. The effective resistance will reduce, causing the current in the circuit to increase. Causing the current in the circuit to increase. Causing the current in the circuit to increase. This causes the terminal voltage to increase. This causes the terminal voltage to increase. Right. Terminal voltage to increase. Right. Look. Next one. Terminal voltage depends on the internal resistance of the voltmeter used to measure the voltage. Correct? No? Correct? No? Now look at this. Now, let's say third one. Cell is there, internal resistance. I am connecting a voltmeter. Let's say this is a real voltmeter, resistance is there. Depending on the resistance, the current will change. Depending on the resistance, the current will change. When the current changes, terminal voltage will change. Correct? No? P is also correct. Right there. Depending on the resistance inside the voltmeter, depending on the resistance inside the voltmeter, the current in the circuit will change. The current in the circuit will change. Therefore, the terminal potential difference will change. Therefore, the terminal potential difference will change. Terminal potential difference will change. Right, look. Next one. The cell becomes warm when its terminals are short circuited. What do you mean by short circuited? Short circuited means connected together. Look, look. What do you mean by short circuited? Now, if you connect this with a non-resistant wire, short circuited, E times R, will current pass through? Yes. When current is going through the resistor here, what will it produce? It will produce heat. It will produce heat. I squared simple R. Heat is produced. That toss indicates there is an internal resistor. Correct? Correct? No? That toss indicates there is internal resistor. Right there. When current passes, when it's short circuited, due to the heat produced by the resistor, due to the heat produced by the resistor, due to the heat produced by the resistor, we can say there is an internal resistance. We can say there is an internal resistance. Right. Terminal voltage measured with the ideal voltmeter shows 1.5 volt. Right. What do you mean by ideal voltmeter? I'll do that here. Now, ideal voltmeter means resistance is infinite. You know this. Resistance is infinite means current is going to be what? Zero. Current is zero means delta V is equal to E minus I is 0 times simple R. Potential difference is equal to the battery EMF. Potential difference is equal to battery EMF. The battery EMF is 1.5 volt. So we don't know whether there is an internal resistor or not. Why? Ideal means current can't go. No? Whether you have a resistor or not, current can't go. So we can't say. So this does not indicate that there is an internal resistor. Okay, no? Right there. When we connect the ideal voltmeter, when we connect the ideal voltmeter, when we connect the ideal voltmeter, there is no current passing through the circuit. There is no current passing through the circuit. So the terminal potential difference is equal to the EMF. So the terminal potential difference is equal to the EMF. Terminal potential difference is equal to the EMF. Terminal potential difference is equal to the EMF. So we cannot predict whether there is an internal resistor or not. So we cannot predict whether there is an internal resistor or not. Right. Okay. Read the question. A sinusoidal voltage is applied across the resistor. The power dissipated by the resistor with time is best represented by power is equal to I squared over R. Now sinusoidal means what? There is a positive side as well as a negative side. Think and tell me. If a positive side comes, positive answer. If a negative side comes, negative squared, still positive answer. Since the current is going like a sine curve, power is also going like a sine curve, always positive answer. Correct answer is answer number 2. Right there. Right there. When a sinusoidal current passes through, when a sinusoidal current passes through, the current is squared. The current is squared. So whether it is positive or negative, so whether it is positive or negative, the power will always be positive. The power will always be positive. Power will always be positive. Right. Look at this carefully. Look at this. The cell in the circuit shown has negligible internal resistance. Negligible internal resistance. As the pointer P moves from A to B. Now A here, B here. Right. The potential difference Vx is. Potential difference is taken from the ground, Vx is. Right. Be careful, this is positive, this is negative. Huh? Positive, negative. Huh? Right. So let me go back to the board to represent this carefully. Look at this carefully. So here, negative, positive, grounded. Here you have a resistor. We are moving the pointer from A to B. So this is 0 volt. This is going to be minus 10 volt. Potential difference here, 0 minus 10. Potential difference is going to be 10 volt. Whether you like it or not. Right? No? So here, if you take 0 volt, high potential to low potential current will travel. So don't worry. High potential to low potential current will travel here. 0 volt is high potential. Minus 10 volt is low potential. High to low current will travel. Okay, right. Now, if you keep a pointer here, what does that mean? Here 0 volt, here also 0 volt. What's your voltage there? Vx. So potential difference. Here 0 volt, here 0 volt. Potential difference is also 0 volt. Next one. Here you go. Resistor is there. Resistor is there. I keep the pointer here. What is the potential difference? Here 0 volt. Here you have minus 10 volt. The potential difference there, carefully look. Potential difference there. So potential difference if you take, here 0, so here minus 10 volt. Here minus 10 volt. So now if you plot the variation, you are moving from A to B. If it's at A, 0. If it's at A, 0. At B, well, it's going to be minus 10. Check and see whether this variation is there. Well, this variation is there. 11th one, answer number 4. 11th one, answer number 4. Right. Write down. We can find the voltage as indicated below. We can find the voltage as indicated below. Right. Okay. Moving on. Question number 12. You can see now they have loaded the last bit with electricity question, but easy one. Circuit shows a cell of EMF E internal resistance R connected in series with a variable resistor R. Which of the following best represents the variation of current I with resistance R? Right, let's apply Kirchhoff law here. So all of you all know sum of EMFs equal sum of potential differences minus 2 plus positive I times simple R, I times capital R. R is your variable. Looking at this I and R, let's take I and R the subject, then it's easier here. I is taken out. Okay, let's look at this. R is equal to 0. When capital R is equal to 0, I is equal to E divided by simple R. E divided by simple R. Right. Next, R can be increased to infinity. R can be increased to infinity. So I is equal to E divided by simple R over capital R. Look at the board carefully. R tends to infinity. Simple R plus capital R also will tend to infinity. Something divided by infinity, current will tend to 0. Current will tend to 0. So it's coming to 0 means it's not this, it's not that. Not this. Either one of the two. Is it a linear variation or non-linear variation? I and R are inversely proportional to each other. Non-linear variation. Correct answer is answer number 1. Correct answer is answer number 1. Right there. We can check the current when R is equal to 0 and R is tending to infinity. We can check the current when R is equal to 0 and R moves to infinity. From this we can build the basic relationship. From this we can build the basic relationship. Because current is inversely proportional to resistance R. Because current is inversely proportional to resistance R. Okay. Right. Okay now. Okay. Next one. Circuit A and B are used as identical cells with negligible internal resistance. So easy for us. Switches S in both the circuits are closed in time t equal naught and left for a long time. Which of the following best represents the variation of potential difference across R with time? Right. Now remember battery will get weaker. Here there is one 5-volt battery. Here there are batteries in parallel to each other. So when here the voltage will always be 5 volt. Here also voltage will be 5 volt. But after some time, this will start discharging and it will reduce. So B will reduce quickly. B will reduce quickly. So B reduces quickly, A goes for a long time. Correct answer is answer number 4. Right there. The voltage across the resistor will be 5 volt in both the circuits. The voltage across the resistor will be 5 volt in both the circuits. The voltage will be 5 volt across both the circuits. A single battery will discharge quickly. A single battery will discharge quickly. A single battery will discharge quickly. But 3 parallel batteries will operate for a long time. 3 parallel batteries will operate for a long time. 3 parallel batteries will operate for a long time. Okay, now? Right. Question number 14. Voltages applied across the silicon resistor shown are represented in symbols. Represented in symbols as indicated below. Right. Transistor will operate in the active region. Now, that day we learned this. We have cutoff. VCE equals VCC. Saturated. VCE is approximately 0. Active. VCE is between 0 and VCC. Transient operating means, optimal operating means, we say VCE is approximately VCC divided by 2, right? For this to occur, for these two to occur, base emitter should be what? Minimum, forward bias. Minimum 0.7 or above. Greater or equal to 0.7. Right now. So if you look at this now, there is no value, so don't panic. So VB is 0.7 and VC is 5 volt. Normally to bias they use 10 volt. So 20 or 10 volt. So 10 divided by 2 is 5. So correct statement is this. Now for that you should know what you call, you have done transistor problems, then quickly you will realize these conditions are directly satisfied there. Right there. As shown below, in the active region, base emitter is forward bias. In the active region, base emitter is forward bias. In the active region, base emitter is forward bias. And VCE should be approximately VCC divided by 2. And VCE should be approximately VCC divided by 2. Okay, no? Right. Next one. A beam of positively charged particles passing through point A in the upward direction and an electron passes through B. Is the electron, huh? Is the electron, right? the direction of the electrostatic force and the magnetic force on the electron are such that, okay, electrostatic force, look at the board now, right? So because of this current here, there will be a field inwards, magnetic field inwards. Because of this current, there will be a field inwards. Apply left hand rule. Field, electron going down means current is up. Field, current, force. So magnetic force will be in that direction. Magnetic force will be in that direction. Again, look. Because of this current, there will be a field inward. That means left hand rule. Field, electron going downwards means current up. Field, current, force. Magnetic force in that direction. Magnetic force in that direction. Right. Now what? So magnetic force in that direction will be active. Okay. Next. They are asking the electrostatic force. They are asking the electrostatic force. So look at this. Negative is attracted to positive. Negative is attracted to positive. Negative, positive means attractive force. Electrostatic force also same direction. So magnetic force and electrostatic force both are in the same direction. Magnetic force and electrostatic force both are in the same direction. Correct? Right there. Due to the current in A, there will be a magnetic field acting on B. Due to the current in A, there will be a magnetic field acting on B. There will be a magnetic field acting on B. By applying Fleming's left-hand rule, we can find the magnetic force. By applying Fleming's left-hand rule, we can find the magnetic force. By applying Fleming's left-hand rule, we can apply the magnetic force. Find the magnetic force. And the electrostatic force will be an attractive force. And the electrostatic force will be an attractive force. Right. The curve shows the variation of absolute humidity. No problem. Relative humidity of air volume corresponding to. So, actually, you all know the graph. Temperature RH. So, RH will increase and then become fixed from C. This is your dew point. This is your dew point. That is where saturation occurs. Here RH is 100%. Right. Okay. First one. At point A, it can be 100%. Can't know. Point A is here. Point B is somewhere here. It can't be 100%. First one is wrong. Point B can be 100%. Wrong. Point A and C can be the same. A and C can be the same. Wrong. RH is different. Point C can be less than 100%. Wrong. Point C guaranteed 100%. Saturation occurs. D can never be less than 100. That is your correct answer. 56, answer number 5. I have drawn the graph there. These are basic graphs which you learn when you do what you call humidity. Okay. Right. Next one. Two masses A and B. One mass is M, the other mass is 2M, but same volume. Same volume means same radius. Huh? So same volume means same radius. But actually, because they didn't say spherical, because you can apply Stokes equation for a sphere. They gave all for this. But now let's say we look, your A-level exam, they give the word sphere. Same volume means same radius. So terminal velocity, same volume means same radius. Same radius. Right. Are released from a deep pond. Which of the following graphs best represents the variation of the speed? Right. Now look. Weight is there. Upthrust is there. Viscous force is there. Same radius. Here 2 mg. Same radius, same upthrust is there. 6 pi eta RV. Same viscous force is there. So look at this. Larger resultant force. Larger resultant force will take a longer time. So technically B takes a longer time. B takes a longer time to reach terminal velocity. Here B takes a shorter time. That's wrong. Here A and B reach at the same time. Wrong. A and B are going together. Wrong. A and B will not go together. Resultant forces are different. They will have different acceleration. Here they reach the same terminal. That's also wrong. So what can you say? Actually, heavier mass will take a longer time to reach a bigger velocity. Lighter mass will quickly reach terminal velocity. If they gave you spherical, correct answer is answer number 2. Right there. Since it is not given as spherical, they had to give all. But if it was given as spherical, the heavier mass will reach a larger terminal velocity. The heavier mass will reach a larger terminal velocity. Than the lighter mass. And the heavier mass will take a longer time. Okay. Right. Next one. A non-viscous incompressible, that means Bernoulli, flows through a pipe. Now remember this part of the pipe. This part of the pipe is exposed. Here guaranteed stagnation point. Here velocity V. Here particle comes to rest. So here pressure P1. Here pressure P1. Here atmospheric pressure. Here pressure P2. Here also atmospheric pressure, right? They are giving you if the pressures measured by A. Pressures measured by A is P1 equals PATM plus. Difference here is different. H rho G, H1 rho G. So pressures measured by A is P1 and P2. They have measured the pressure. So if you apply P1 plus half rho V squared equals pressure P2, stagnation point, no velocity. P2 minus P1 is half rho V squared cross multiply 2 times P2 minus P1 divided by rho whole thing square root, that is your velocity. So 2 times P2 minus P1 divided by rho, which means correct answer is answer number 1. Correct answer is answer number 1, right there. Near tube B, there is a stagnation point. Near tube B, there is a stagnation point. Near tube B, there is a stagnation point. Right, stagnation point. Okay, now. So the velocity will become 0. Right. A cork is attached to the bottom of the beaker and it stays underwater. The beaker is rotating at constant angular speed. Which of the following indicates the correct position of the cork? Remember, cork is less denser. Cork is less denser than water. That means the object is less denser than the medium. Object density lesser than medium density. What does that mean? Normally when it rotates, we should feel centrifugal force going away. But if the object is less denser than the medium, the centrifugal force is towards. Which means correct answer is answer number 3. Right there. The object is less denser than the medium. Object is less denser than the medium. So when rotation takes place, there should be a pseudo force acting on the cork. There should be a pseudo force acting on the cork. There should be a pseudo force acting on the cork. And the pseudo force will act towards the center. And the pseudo force will act towards the center. Now, imagine if there was a metal ball, let's say you're rotating around this, where will this slant? It will slant away. Why is that? Why is that? Why is that? Reason being, density of metal is greater than the medium. Medium is air. So pseudo force will act away from the center, opposite to the acceleration. This is in the direction of the acceleration. Okay, now? Right. Final one. A bar magnet is dropped with the axis vertical. It's accelerating through. Accelerating through. So when a north pole is coming to oppose north pole occurs here. Anti-clockwise current. Anti-clockwise current. The faster it is falling, the greater the magnetic field. Greater the magnetic field. Right. Then what happens once it passes through? What happens once it passes through? The induced EMF will occur to oppose the change. Oppose means it's keeping on going. We need to attract it. So from the bottom north pole. If I look from the bottom north pole anti-clockwise, top it will be clockwise. From the bottom, it should be anti-clockwise. From the bottom, anti-clockwise means, from the top, if you see, clockwise. Clear? So if you look at this carefully, which graph? Since it's falling with the greater speed, this is your most suitable one. And look at this. This area here and this area here will be what? The same. That means the flux when it enters and the flux when it goes away should cancel each other off. Right there. As the north pole is coming towards the loop, more magnetic field lines will start linking with the coil. More magnetic field lines will start linking with the coil. To oppose this, current will travel in the anti-clockwise direction. Current will travel in the anti-clockwise direction. And as it passes, the number of field lines linking will reduce. Therefore, a north pole is created from the bottom. Therefore, a north pole is created from the bottom when viewed from the bottom. When viewed from the bottom. This will cause current to go in the opposite direction. This will cause current to go in the opposite direction. Because it's traveling very fast, the EMF will be larger. The EMF will be larger. Okay, EMF will be larger. Right. Okay, structured essay. Third structure. You are provided with a uniform glass tube open at both ends, a tuning fork, 512 Hertz, tall vessel containing water, experimental arrangement set up to determine the speed of sound in air using method of resonance. So basic principle. Draw a diagram to illustrate the setup. Tall water vessel, resonance tube is there, small height, and don't forget here, tuning fork is vibrated, kept above the mouth. Also, to measure the length, you will have a scale here. You will have a scale here. Scale is connected. Scale is connected. Okay, now? Scale is connected. Right. If you want, you can quickly name it. Tall water vessel. Tall water vessel. Tuning fork. Tuning fork. Linear scale. Resonance tube. Resonance tube. Right. State correctly the correct procedure to obtain the resonance state. Insert the tube. Insert the tube into water such that the vibrating length is very small. Vibrating length is very small. Vibrating length is very small. Second one. Vibrate the tuning fork. Vibrate the tuning fork. Place it over the resonance tube. Place it over the resonance tube. Over the resonance tube. And gradually pull the resonance tube out. And gradually pull the resonance tube out. Resonance tube out. Right. What will you hear? At a particular instant, a loud sound is heard. A loud sound is heard. Measure vibrating length. Measure vibrating length. We always start with a small vibrating length. Vibrate the tuning fork, keep it over the resonance tube. Gradually move the resonance tube out until a loud sound is heard. Right. What are the two readings that you would obtain when finding the resonance length? So two readings are, one reading is reading at the top of the mouth of the resonance tube, reading at the liquid level. These are your two readings. That's right. First one, reading at the open end of the tube. Reading at the open end of the tube. Next one, reading at the liquid level. Reading at the liquid level. Reading at the liquid level. Okay. Right. Okay. Actually, there is few more questions which is not printed here, which I will do. Maybe the page has got disappeared. There is a part D. Write the part D will. Find a relationship for the vibrating length. So find a relationship for the vibrating length. So look at this carefully. Now here if you take lambda divided by 4 is equal to vibrating length. If you take the next vibration, half and quarter, 3/4. 3 lambda over 4 is equal to how much? L. If you take the next vibrating length, pi lambda over 4 is equal to L. So what are they telling you? Lambda divided by 4 times N is equal to L. Where N is going to be odd numbers, 1, 3, 5. 1, 3, 5, 7, etc. Okay, no? This is your part D. This is your part D. Okay. This is your part D. Right now? Okay. Essay question number 1. This is the essay 1, electric field 1. A proton of charge Q and mass M. Proton of charge Q, mass M, is set up to travel along the path A, B, C, D, E through small holes. So here what's happening? Here the charge is passing through. It has been done by applying a uniform electric field between the plates and a uniform magnetic field outside the plate. AB and CD are straight paths of length D. BC and DA are semicircular paths of radius R. Each pair of plates is subjected to a potential difference V. Neglect gravity. Answer the following question. Write down expression for the electric field between the plates. So electric field is equal to potential difference divided by distance. Going along ABCD path. Positive, negative. Positive, negative. Yeah. Positive, negative. So here, this is the path taken. This is the path taken. The positive, negative means here the electric field is going to be in that direction. That is the direction of the electric field. You can carefully indicate it there. That's the direction of the electric field. Okay. Then electrons are attracted here, positive to negative. So here also electric field is from C to D. C to D. So you can indicate their directions carefully. Right. Okay, no? Next one. A proton is initially released from rest at hole A. Obtain an expression for the energy and speed of the proton at B. Right. Proton here, if I release, because of the electric field, there will be a force. Because of the electric field, there will be a force. That force is a uniform force. So electric force is equal to electric field strength multiplied by the charge. What is the charge here? Charge is simple Q. Charge is simple Q. Right. So what is the work done? Force multiplied by displacement. EQD. This work done is the gain in energy. Work done equals gain in kinetic energy. That is equal to EQD. Right? EQD. So here half m velocity v1 squared EQD. Velocity is equal to 2 EQD divided by simple m square root. 2 EQD divided by simple m square root. Right. Derive an expression for the magnetic flux along the path C. Along the path C. Right. Go back. What's happening here? What's happening here? Now here the charge is going in a circular path. If it's going in a circular path, somebody should provide the centripetal force. Magnetic force will provide the centripetal force. Here you have velocity. Fleming's left-hand rule. Force is here. Field should be inward. Current is there. Field inward. So magnetic field is acting into the plate here. Into the region here. Left-hand rule. Field, force, current. This way. So what are they telling you? What are they telling you? So I've indicated the direction there. Centripetal force equal mass into centripetal acceleration. Centripetal force is given by the magnetic force. Centripetal acceleration velocity v1 squared divided by radius simple r. They are telling you there. They are telling you it goes in a circular path. The magnetic field strength is BQ velocity V1. MV1 squared over simple R, 1V1 cancel off. Magnetic field strength is equal to MV1 divided by RQ. M over RQ square root V1 2EQD divided by simple M. The magnetic field strength here, carefully do. So here 2 is there, E is there, D is there, M is there. Q goes to the bottom. Square root 1 over R. Square root 1 over R. Square root 1 over R. Remember, you must be smart enough to substitute for the electric field here. E is V over D. QD over simple M. DD cancel off. 2VQ over simple M square root. Even here substitute carefully. Here substitute carefully. Here for V1 you can substitute. Look at this carefully. V1 is 2VQ divided by simple m. 2V simple m Q square root 1 over R. 2Vm divided by simple Q 1 over R. Okay, no? Right. What is the speed of the proton when it enters the hole C? Give reasons for your answer. So what can you say about the speed? Speed will be the same, no? 2VQ over simple m. Right there. The speed will be the same because it is traveling in a circular path. The speed will be the same because it is traveling in a circular path. Right. Right. Obtain an expression for the new energy and the speed when it leaves the hole. Look at this now. Now already there is a kinetic energy, speed. Already there is a kinetic energy. Further there is work done. Further there is work done. So what's the kinetic energy here? Total energy initial equals total energy final. Total energy initial half m velocity squared. Half m velocity squared. Velocity squared is going to be how much? Square root 2VQ over simple m squared. Speed plus. I'm doing some work. Electric force into distance. Final energy will be kinetic energy half m Vd squared. Be careful now. Here half m 2VQ over m. mm cancel off VQ. Here EQD half m Vd squared. Look at the board now. Simplify it carefully. mm cancel off, vv cancel off. vq plus E is v over d. qd half m vd squared. dd cancel off. vq 2vq. 2vq is equal to half m vd squared. vd is equal to 4vq over simple m square. 4vq over simple m square. 4vq over simple m square. Right now. So here it enters with a velocity v1, leaves with a velocity vd. Leaves with a velocity vd. You can see from circular part speed is same. Here accelerating. Then the remaining circular path also speed is same. Will the magnetic flux obtained in Roman 2 sufficient to guide the proton along dA? Answer is no. Now centripetal force equal mass into centripetal acceleration acting to the center. Magnetic force B dash, charge is the same, velocity is Vd, dqd. M Vd squared over same radius, Vd cancel off. B dash q, mvd over r. What is the magnetic field? B dash, mvd. What is the velocity? 4vq over simple m. 4vq over simple m. rq. 4vq over simple m. rq. Simplify this. B dash. O V M goes on top. Q comes to the bottom. Square root 1 over R. So look at this. 2 over R or root 2 times 2Vm over R. What is 2Vm over R? Go back. Go back. 2Vm over Q times R. New earlier magnetic field. Earlier magnetic field. This is 2VQ. 2VQ, sorry. 2VQ. So root 2 times the earlier magnetic field, B dash. The magnetic field strength has increased. Right there. Magnetic field strength has increased. Okay. Briefly explain how this setup can be used to accelerate the proton. So how can you explain? A to B, speed increases, speed is constant. C to D, speed increases, speed is constant. Again increases, again constant, increases, constant, increases. Every half a cycle through the plates, the speed will what? Increase. Okay, no? So what is happening here? Starting from rest, work is done, acceleration. Then with that kinetic energy, it is sent here. Again, acceleration. With that kinetic energy is changed here, acceleration. Now, when the speed changes to have the same radius, magnetic field should also what? Change. Here, magnetic field is B, here root 2B. Alternatively, the magnetic field will keep on what? Increasing by root 2. So here root 2B means here 2B. It will keep on increasing by root 2. Right there. Every half cycle, the charge is accelerated through the plate. The charge is accelerated through the plate. And it travels in a circular path. And again, the velocity is increased. And again, the velocity is increased. So here increases, constant, here increases, constant, here increases, constant, here increases, constant, here increases. Like that, as it keeps increasing, to have the same radius, magnetic field will also what? Change. So as it increases every half cycle, alternatively, the magnetic field will also increase. Alternatively, the magnetic field will also increase. Right now? Is it clear? I hope you understood that. So again, if I go from the beginning before I go to the last part, look at this. So what's happening here? There is a uniform electric field, proton accelerated, goes in a circular path, again accelerated. So what's happening here? This is what a cyclotron is. What you call it a cyclotron. So here, work done is equal to gain in kinetic energy. For E, we can substitute here. For E, we can substitute. Here. Carefully look. For E, we can substitute this V over D. Right. Going in a circular path, who is providing centripetal force? Magnetic force is provided by centripetal force. Here you'll go the magnetic field. Now again it enters, same speed throughout, again enters with the same speed, but now it's going to increase. So total energy at C equal total energy at D, work is being done by the field. Fe times D. Simplify it, you will get 2VQ, cross multiply, VD can be found. You can see the velocity as actually root 2 times. To go down, velocity is 2vq. Here, there's another 2 inside, root 2 times, increase by root 2 times. Will the magnetic field obtained be sufficient? Answer is no. Velocity has increased means same radius, magnetic field should change. See, velocity has increased by root 2 times, magnetic field also increased by root 2 times. What's the reason for this? The reason for this is very simple. BQV is equal to mv squared over radius, v cancel off. R is equal to mv divided by bq. R is constant, mass is constant. Charge is constant, you can see v is proportional to b. If velocity becomes root 2 times, magnetic field also becomes root 2 times. Right. So what's happening here? Here, velocity increases, constant velocity increases by root 2, magnetic field also increases by root 2. Here also it will increase. Again, magnetic field will change according to the velocity. So, when the velocity is changing, magnetic field will also what? Alternatively change. Right. Last one. Can this process be done in air? Answer is no. Answer is no. Why? Proton will collide. Proton will collide with other particles. Proton will collide with other particles and lose energy. And lose energy. Therefore, it is done in a vacuum. It is done in a vacuum. Okay, no? Therefore, it is done in a vacuum. Right. Okay. So, what does that mean? Now, that concludes week 2, day 3. 60 MCQs done. 3 structured essay done. 3 essays done. Right. Okay then. Enough for today. Keep on working. Now tomorrow I'll be adding to you all the week 3. Day 1, day 2, day 3 papers. That is the 2001 A-level paper. So we have finished. We have finished 2000 A-level paper. 2002 A-level paper, done. Altogether, how many? 60 MCQs here, 3 structure, 3 essay. Here, 60 MCQs, 3 structure, 3 essay. Altogether, how much we have finished? 120 MCQs done. 120 MCQs done. 120 MCQs done, 2 weeks. 6 essays done, 2 weeks. 6 structured essays done, 2 weeks. There is nothing called miracle. You have to work, the miracle will automatically happen. Okay then. Be disciplined, be committed, guaranteed you will get the result. Okay then. See you all next week.